Okay, in this video, I'll be going through the PHS 2021 4E Pure Science paper. So in this video, I will cover question 1 and 2. Now, if you look at question 1, it is very interesting because normally when we do kinematics, right, we deal with a one-dimensional motion, meaning that, for example, if I launch a ball upwards, it will come back down once it reaches its maximum height. Then after that, the ball will basically come back down, right? Yeah. So normally we represent it by drawing on a different column, right? But in this case, it is actually a 2D kinematic question. So for example, if the ball is in what we call a parabolic motion, parabolic refers to this graph, right? You can see that it is curved, right? So for example, if I want to find the velocity of the ball at this position, the velocity vector will be given by this tangent, right? And you can see that this velocity will be slanted. So to actually do the mathematics for a velocity that is slanted, we usually express it in terms of its horizontal component and its vertical component. So it's like a vector diagram whereby the resultant velocity can be given by Vx plus Vy, right? So this you will learn it in JC. So then you may ask, hey teacher, then does it mean that this is not in our syllabus and therefore this question should be void? No, I think PHS did a very skillful way to water it down. So what do you need to know is that for a one-dimensional motion, normally when the object is at its maximum height, we say that the velocity will definitely be v equals to 0. But for a two-dimensional object like this, you can see that the parabolic path goes like that, right? So meaning that if, let's say, the object reaches its maximum height, what we can say is that actually the v in the y direction is 0. But because this object is still moving forward, so we say that the Vx is still equals to something. This is also the reason why that when the ball is actually at maximum height, there is still speed. So you also notice that they didn't use the word velocity here and they used the word speed. And this is how PHS try to water this JC kind of question down to the secondary syllabus. So the key learning point for this question is for one-dimensional motion, maximum height, definitely KE will be equals to 0 because the speed or the velocity will be 0. But in a two-dimensional parabolic kind of motion, when the object reaches the maximum height, only the v in the y direction, that means the vertical direction, is 0, but the velocity in the x direction will be equals to something. So as a result, even at maximum height, the KE will be still greater than 0. There is still KE in another word. So once you understand this, then this question will be quite easy, and I think PHS just want to give an easy question at the beginning. So for part A, you just need to use the kinematic KE formula, but of course PHS is not so straightforward. They actually gave you the mass in gram, so you need to turn the gram to kg before you can get the answer over here. Next, in part B, they are asking you how much GPE is being gained. So when you talk about GPE gain, of course you will be smart if you set h equals to 0 here, and you just need to know how much GPE is gained, just like that. So therefore you will be using MGH, and you can actually directly sub in the maximum height into the formula. Just take note that your mass must be converted into kg, and your final answer should be given in 2SF. As you can see over here, all the input value are in 2SF as well. So that is for part B. For part C, basically you do not use half mv squared because you do not know the speed. So what you can do is that when cases like that happen, whereby, so I know that some of you, whenever you see a question that, oh, determine speed, then in your mind you quickly like, oh, okay, v equals to distance over time, v equals to f lambda, and then you're like, okay, none of it works. Yeah, because in pure physics, we do not always find formula that start off with the parameter that we want. So in this case, because you know that it is a energy kind of question, you will see that the speed over here is being embedded in one of the terms. So how? In this case, if you find that none of the formula in your mind works directly, then it is best to actually write out an expression that describe what happens. So what do I mean by describe what happens? So here you can see that the ball is being kicked into the air, and we can assume that the energy over here at the start and that particular point in the path, the total amount of energy between start and maybe point B must be the same. So what I've written here is the word expression that the kinetic energy of the ball at the start must be the same as, because now the ball has increased in height, so there's a gain in GPE from the ball, and of course there is the kinetic energy because it's still moving, you see. So when the ball is being kicked at first, this is the kinetic energy at the start. Then after that, the ball will go through this parabolic path, and then it will reach its maximum height, right? This is the maximum height. So for whatever energy that you put in at the start, this amount of energy will be converted to your GPE, right? And because the ball at this point is still moving, right? There's still a velocity forward. So therefore, you will have the second component, which is kinetic energy at maximum height. Now, if you substitute all the things in, you will be able to see that on the left side, you will have 82. So when I do a physics expression, I like to do it left side, right side. So left side, 82. Right side, the GPE term we have already found. So like mathematics, we do not use the round value for theory paper. Okay, so for theory paper, we assume that, you know, it is like mathematics. Okay, then after that, we have this kinetic energy at the maximum height. That means the KE over here. So we do not know how much KE is here, but we know that this KE has to come from whatever KE at the beginning. So this KE at the start, some of it will turn into this, some of it will turn into gain in GPE, right? So therefore, we have this term. For the second line, what I do is that I bring the 61 over here. That's how I get 20.5. You do your mathematics and you solve the equation, you'll be able to see that the answer is actually 10 meter per second. Okay, now for the second question, basically it is a moment kind of question. As you can see here, they actually tell you that there's a pivot. So what happens is that when you apply a force, basically the round object will get lifted up like that from its original position here. So to the object, it is basically a turning effect. Yep. So for part A, again, I think PHS is really trying very hard to train their student to see the prefixes. So you can see that the mass is given in gram. So I teach you to use a star to actually help yourself. And you can see that this is the formula you use. You'll be able to get 0.40 Newton. Okay, for part B, PHS actually bring up the difficulty by making it like a geometry question. So let's go back to this. So here you see that there are actually two forces in play. One is of course the weight over here, which I highlight in green. Okay, the other force is of course the pushing force, the blue one. So these two forces will provide a different moment to the object. Now I just want to highlight to you that if in a normal case, there should also be a normal contact force over here from the ground onto the barrel. But because down here, they are saying that the ball is being oh no, sorry. So for now, I read the wrong question. So for B, I'm just asked to find the moment caused by the weight. Okay, so I'm purely focusing on the red arrow. Okay, this one. So in order to find this moment produced by the weight, definitely I will need the perpendicular distance here, d. So I do not have d, but I can see that there is a triangle being formed. So I have r over here, which is this line. Okay, then after that I have this green line, which is your radius minus 10. So the 10 comes from here. Yeah, and then of course I will have what I need, which is the perpendicular distance that I needed to calculate the moment of the weight. So here you can see that it is a right angle triangle. So therefore you can use a Pythagoras theorem and you can find the perpendicular distance. Now be very careful, the d that you are finding right now is in cm. But the moment that you are required to find is in Newton meter. So just be careful with that. So now that you know the perpendicular distance is square root 200, you can then find the moment of the weight, which is just the weight times the perpendicular distance. So here the weight is 0.4, we have already found it. Like I said, be careful, the square root 200 is in cm, so you need to change it. My usual way of presentation is that I will write the long one, and then after that I will round it up and I will tell the marker that I have rounded it up. Now for part C, so just now for part C basically we need to do a bit of balancing. So how do I know that it is balancing? Because of the word like just lifted the ball. When the ball is just lifted up, that means it's just enough to do that. So we can equate the different moments together. And because the ball is lifted off the ground, now technically that whenever there's an object touching another object, there will be a normal contact force. So normally there will be normal contact force 1, and of course the pivot here will also have a normal contact force number 2. But because we are dealing with moment, and this normal contact force is directly on the pivot, so it won't really appear in our formula. So I won't be caring about it. Now because the object is just barely lifted from the ground, we would also know that this normal contact force will be equals to 0 Newton, simply because the barrel is just lifted off the ground. So we can basically equate the normal contact force there to be 0, and as a result, basically now your diagram will only have basically now your diagram only have two forces that will actually cause a moment. One of it is the pushing force, the other one is the weight. So the pivot will be this guy over here, P. So I hope you are able to see that the red arrow, the one, the weight, will actually cause this is a clockwise moment. So I will have clockwise moment number 1. And then if you look at the pushing force and this pivot here, I hope you are able to see that this force will actually produce an anti-clockwise moment. So I only have two forces that will cause a moment. So since the barrel is just lifted up, I know that this moment and this moment must be the same. So in your presentation, it is important to actually highlight where is the pivot, and then don't forget it is the sum of clockwise equals to sum of moment anti-clockwise. So for the clockwise moment, it will be the weight, right? And we have already found it. It is 0.057. So down here, sorry, the anti-clockwise moment, the weight is, okay. So I think I make a mistake over here. So this should be anti-clockwise and this should be clockwise. So the weight multiplied by square root 200. So this will actually give you Newton cm. That's why I didn't sub this value directly inside, because the root 200 is in cm. Then for the other side, it is just the unknown pushing force multiplied by its perpendicular distance. So if you refer to here, you can see that the line of action of F, which is here, right, will basically make this perpendicular distance, right? So let me draw it out. This one, this is the line of action of F, can see, okay, and this will be the perpendicular distance. So this perpendicular distance, the light blue one, will correspond to this. So that's how I get this. Okay, so if you solve all your thing, like I said, my style of presentation is write the full thing over here, and at the answer I will indicate this. Okay, for the last part, for your part D, what do they mean by this? Keep the line of action towards the ball. So this is the new force. The line of action of the new force is directed to the same center. So this is what the first sentence means, right? And it says that the angle is from the ground is increased. So the ground is of course the black line, and of course this is the angle that has increased, right? So I have drawn this diagram to illustrate to you what is the effect. So when you look at the O force, this is the line of action, and as a result, you can see that the perpendicular distance is this, right? Can see? Okay, now that this is done, I will erase it so that you can see clearly, right? So now if my new force is at an angle, what would be the impact in the moment that it creates? So this is the line of action of the new force, and you can see that the perpendicular distance is here. And if you can recall, the new one is definitely shorter than the old one, right? So you can see that the effect, right, of theta is that if theta increases, what happens is that your perpendicular distance will decrease, right? And when your perpendicular distance decrease, the moment caused by F will of course decrease as well, right? So this means that if the moment caused by the same force decrease, it means that to leave this barrel, you will need to apply a much larger force if your theta becomes larger and larger. Okay, so now let's look at how to phrase all this here. Like I said, always plan. So this is my plan in my brain. So quickly I will put down my conclusion. To create the same amount of moment, because the perpendicular D is dropped, I will need a greater F, right? Then now I try to pen it down. Now when we say it and when we pen it down, there is a difference. When we say it, we can say perpendicular distance, perpendicular distance. But when we pen it down in an exam condition, it is important for you to be able to quote that it is the perpendicular distance between the line of action of the force. So you need to know what do you call this dotted line, right? This dotted line, dot, 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 dot. This is called the line of action of the force. You must know these terms, right? So the perpendicular distance between the line of action of the force and the pivot. Okay, you need to phrase it. So when we are talking to each other, we can say perpendicular distance drop. But in exam, we need to give the full form. Okay, then we will say that, oh, when there's a theta there, when the angle is bigger, the perpendicular distance will drop. Now, then after that, because you need to explain, so when you explain by quoting the related formula. So because m, the moment, is a product of F times D, now that the perpendicular distance D has dropped, this means that I would need a larger force, right, to produce the same moment about P. But if you are just answering that, then the marker can say, hey, which moment are you talking about? Are you talking about the clockwise moment, or are you talking about the anti-clockwise moment? So therefore, it is very important for you to say this. Yeah? So normally when you want to talk about moment, the generic format will always be clockwise or anti-clockwise moment. Right, then after that, please tell me caused by which force. Right, then after that, don't forget there is a special preposition behind about, and tell me where is the pivot. So now that this is the format that I request from you, right? You may ask, hey teacher, you tell me that I need to state this, then I compare your answer. Your answer got, okay lah, CW, okay, fine. You talk about moment, fine. You say about P, okay, fine. Okay, you have all this. How about this? Why didn't you say this? I got ma? No, I say already. A larger force is required. right? This refers to F0. Yeah, okay, this is the end of my